Hello guys, I hope I am audible to everyone here. So this is Technical Avant-Garde. Welcome to the PCB Designing Webinar series that is scheduled from 16th to 20th of June 2020. Today we will be starting with the first session, and today we will be discussing about what PCB is, why PCB designing is to be do so, and some key points of designing PCB, installation procedure of our CAD tool which we will be using, that is KiCAD. And the last and the most important thing is the hands-on project which we will be doing in the whole series. So without wasting time, let's get started. So as the name suggests, PCB is the printed circuit board. Printed circuit board can also be known as printed wiring boards and the printed wiring cards. So these are the three names with which PCB is known in the industry, or you can say in the market, industrial market. So yeah, first question arises, why PCB? What is the need of the PCB? And when PCB is successfully started? So in earlier 1960s, telephone crossbar switches as shown in this picture and in this picture. This is the technique named wrap wiring technique. In this technique, a wire is wrapped over a small gauge, that is, it is shown in this figure and in this figure. In more detail, the wires are wrapped over the round conductive material without soldering them. Like these wires are round on the small gauges, but there is no solder material on these wire gauges. So if anyone plucks that wire over the gauge, that wire might get detached. So in furthermore, in 1960s and 1970s, the later technique, that is the wire wrapping technique, goes higher and higher, more adaptive technique, like people and industry started using more and more. This is the Macintosh wire wrap board. You everyone have heard about the Macintosh. Like this is the Macintosh wire wrap board. You can see how complex is this. So what is the wire wrapping technique? Wire wrapping technique is a technique in which the wire is wrapped over the gauge. It can be automated using the machine in 1980s, but it is very expensive and very time consuming. Like you can say, if an individual person or a machine can do this complex circuit, then how much time it will take? Now what after wire wrapping technique? That's the surface mount technology, which also known as SMT. In 1980s, surface mount technology, that is SMT, came into account, which started growing faster and faster due to two major things. The first is cheap manufacturing cost. As compared to wire wrap technique, the manufacturing cost is very high. And the second thing is faster to produce. And in the wire wrapping technique, which will be comparable, that is time consuming. It was time consuming. Like either it is automated or done by any individual person, it will take a lot of time to do the process. But in SMT technology, it can be done as faster as possible. So this is the first ever used Motorola 68008. In this, SMT technology is used. And one more thing I want to tell you about, that is the plated through holes. I will discuss plated through hole, that is PTH, later in this session. So this is the surface mount technology is linked with the plated through hole technology, that is the PTH. This is the I must say the advanced or the latest example of the surface mount technology. Like you can everybody can see that all the ICs are connected on the surface, and the word says surface mount technology. Like like any component, any electronic component which is mounted on the surface of the PCB, the technology named as the surface mount technology, and the device which is being used in the surface mount technology is known as the surface mount device, SMD. So these ICs are this IC, this IC, this IC, this IC, all these are surface mount devices, and they are connected on the board. They are electrically, or you can say conductively, connected on the PCB via SMT technology. We might be designing this Raspberry Pi later. So let's come to the next slide. Like the first question arises in the designer's mind, or before doing PCB designing, what is PCB? So to answer this question, that is a simple answer. It is a board that supports mechanically and connects electrically the electrical and electronic components using conductive tracks and the pads. I will explain each and every word in this session. So don't worry about anything like you won't able to understand anything. So it is a board that support mechanically and electrically to the electric and electronic component using conductive tracks and pads. And the other features etched from one or more sheets of copper laminated onto and or between sheets layers of the non-conductive substrate. Components are generally soldered onto the PCB to both electrically connect and mechanically fasten them to. So this on the PCB, like I'd shown this picture, like this IC is connected in two ways. Like it has the mechanical support, as well as mechanical support means this IC cannot be displaced after the connection, after the electrical connection, if you can say more understandable. Like it is connected electrically and supports mechanically, like no one can displace this IC without I must say without desoldering it. So if you can desolder the IC, then you can mechanically detach the IC. So you cannot mechanically detach this IC as well as electrically disconnecting that IC before desoldering the process. So the point says components are generally soldered. All the components on the PCB are soldered to have the faster electrical connection and the mechanical connection. To get more on what is PCB, it can have multiple copper layers like 2 layers, 4 layers, 6 layers, 8 layers, and this picture has the Raspberry Pi, which is the 8-layer PCB. So you need not worry about what are the 2 layers, 4 layers, 6 layers, 8-layer PCB. So 2-layer board has the copper layer on both the sides. Like you can connect the components on the top side as well as on the bottom side. But whereas in the multi-layer boards, the 2 layers are sandwiched with the copper layers between layers of insulating material. Like like top layer and the bottom layer are copper layers, and the between the those 2 layers are the insulating layers. Conductors on the different layers are connected with the vias or vias, depending upon the individual how to pronounce this word. Then comes the through-hole component. Leads sometimes also effectively function as via. These two are different terms, like vias and the through-hole. I will be discussing both these terms later in this session. After two layered PCBs, the next step is usually 4 layers. Like after designing the 2 layers, the designer will design the 4-layer PCB if he wants to do that, he or she. So 4-layer PCB, what 4-layer PCB consists of? 2 layers are dedicated to the power supply, like if you want to give the circuit board or the PCB board 3.3 volt, 5 volt, or 12 volt, depending upon the need of the manufacturer or the designer. that is the power supply. If you want to give the 3.3 volt, then you can apply to the 3.3 volt to hold the PCB. And next layer, the two layers are dedicated as the power layer, and the another layer is dedicated to the ground plane, like electrically ground. We will be discussing this also. And the other two layers are used for the signal wiring between the components, like four layers. There are four layers, and two layers, out of which two layers are dedicated to the power supply, like 3.3 volt. I can take the example, and the other is GND, ground. And the other two layers are used for the signal wiring between the components. So I'd use this word via. Conductors on different layers are connected with vias. So now let's see what is via. The full form of via is vertical interconnect axis, or you can also say vertical interconnection axis. It is an electrical connection between layers in a physical electronic circuit that goes through the plane of one or more adjacent layers. Like as shown in the figure below, you can see that this is the through hole, this is the blind via, and this is the buried via. This whole diagram is the four-layered PCB. It is the internal layered view of the PCB. If you can say what is blind via is the via or the electrical path which is done by the electroplating process between the first layer and the second layer. This is the first layer, this is the second layer, this is the third layer, and this is the fourth layer. And the blind via is the via which is being connecting the electrical path or the conducting part between the first layer and the second layer, or the third layer and the fourth layer. The buried via, as the name suggests, means that there is an electrical connection between the second layer and the third layer. That is between the top layer and the bottom layer. If you want to make an electrical connection between the second and third layer, you will connect the buried via. Buried via is generally used in the 8-layer or 6-layer PCB. There is no need to define the buried via in 4-layer PCB, and there is no name for buried via in 2-layer PCB. And this is the through hole. Through hole is a process or the technology. It is a THT technology, that is through hole technology, which will be connecting the first layer, second layer, third layer, and fourth layer on a single time. Like you can see that all the red part, this is the the electrically plated part, which is soldered part, which is being connected the first layer with second layer with third layer, and third layer with fourth layer. And all these layers are connected with a single electroplated hole. Via are copper plated holes that functions as the electrical tunnels through the insulating substrate. You can the green part is the insulating substrate, and it is making the hole or a tunnel, electrical tunnel, which is copperly plated to make an electrical connection. So now comes what is the ground plane. I'd use the word ground plane in this. In the 4-layer PCB, 2 layers are dedicated to the power supply and the ground planes. So let's see what the ground plane is. Ground planes are an electrically conductive surface usually connected to the electrical ground. Electrical ground means if you are applying any power supply to the PCB board, then negative terminal or the negative part of the battery or the power supply is the electrical ground. The ground plane is a large area of copper foil on the board which is connected to the power supply ground terminal and serves as a return path from the current from different components on the board. As this statement suggests, like if you are if the current goes from the battery or any component, it will go through the plus or positive side or the power supply side and turns through the component via ground part or the negative part. So as it is made as large as possible, covering most area of the PCB which is not occupied by the circuit traces. Like circuit traces means like the connections between the components. So in the PCB terms, we know PCB terms or PCB design layout terms, we will call the connections as the traces. So ground plane is made as large as possible. We will be defining the ground plane while designing the PCB. So it is made as large as possible. Like if there are traces in, if you want to make a two-layer PCB, and both layer PCBs have the traces, and you also want to make the ground plane in both the planes. So both the layers. So you will define the ground plane on the top layer as well as on the bottom layer, along with the circuit traces with having with the layer. So in the multi-layer PCB, it is often a separate layer covering the entire board, as discussed, as we had discussed in the 3-4 slides back in the 4-layer PCB scenario. The large area of copper also conducts the large return currents from many components without significant voltage drop. This is the main point why ground planes or power planes are situated in the PCB. So there should be no voltage drop in the PCB. Like if you have the PCB, and if you are turning some voltage drop from one corner to another corner, then if you can say, if the corner A has the 3.1 volt, and the another corner has the 4 volt, if you are defining the 5 volt as a total voltage on the PCB, so there is a voltage drop. There should be no voltage drop on the PCB. So to remove this voltage drop, there is a ground plane which prevents or removes the capacitance between the components and the planes. So I had told you about the PTH and NPTH earlier, like plated through hole technology and non-plated through hole technology. So let's overview about what is THT. This is the through hole technology, also called THRU, through hole. This technology hole go completely through the boards. There is, as the name suggests, through hole. Like they have to buried through the PCB, as shown in this photo. This is a through hole technology. Like it is making a tunnel in every layer of the PCB. So this technology was famous in 1970s and 1980s after the wire wrapping technique, but it is still in use nowadays. Like people used to order the PCB and told the manufacturer or the manufacturing industry to have the PTH in their PCBs to have some advantages. So this through-hole technology can be of two types. It will be plated through-hole technology and non-plated through-hole technology. So what is plated through-hole technology, PTH technology? So during the manufacturing process, after drilling the boards, a thin copper layer is plated onto the walls of holes, providing them with electrical conductivity. After the PCB assembly is finished, the link between the components leads. The component leads suggest here that the terminal of the component, as shown in the photo, this gray colored is the components leads, and the copper tracks. Copper tracks means the connection between the components has the lower resistance, which is the main point in the PCB designing. Every component should have the lower resistance so that every component can able to give its higher and higher efficiency and the better mechanical stability, like no component can move here and there uh, while disturbing the PCB. So as shown in this photo, like this is the gray, this gray part, light gray or white part is the solder. Like solder is placed through the electroplated hole. This hole is done by a process named electroplating. So solder is distributed through this entire hole. Like this is the top layer, this is the bottom layer, and this is the through hole pin, and the solder is distributed along with this pin. So now I will compare the PTH with NPTH, so you can understand the things better. So what is non-plated through-hole technology? No copper plated onto the walls of holes. In this, thin copper layer is plated onto the walls. And so the barrel of the hole has no electrical properties. In the PTH, hole has the electrical properties. Popular when the printed circuits only had the copper traces on the one side. If you want to make the single layer PCB, which is highly impossible, I'll tell you why. So in that cases, designer used to design the NPTH because it is simple and this is quicker and cheaper than PTH technology. But you can see, but their use decrease as the number of layer increase. You can also say this thing also, because if number of layers is increased, like you increase the layers from 1 to 2, 2 to 4, then this technology might not be used in another more number of layer PCB. The main advantage of the NPTH is that the as I'd explained, it is simpler and quicker. Like you can manufacture this PCB very quickly because the solder has not been sent whole through the burette. So this is the microscopic cross section of the PCB. Like this is the example of the two-layer PCB, and this portion is the electroplating portion. It is done by the electroplating process. It is a process which is being used to make a hole or through hole or via or a drill. So this white part is the silk screen, like the top layer of the PCB. This is the solder mask of the copper, and this is the surface finish over the hole. This white part is the substrate part, and the same, this is the top layer and this is the bottom layer of the PCB, and this is the microscopic cross section of the PCB. So I hope you have understand the whole process. What is PCB? Why is PCB? We will be having the 10 minutes or 5-minute session after this process. Like you can ask any doubts on the chat. So let's move on about the steps to design the PCB from software, like from any CAD tool to the if you want to get manufactured in hand PCB. So first part is to design the circuit, then create symbol. If you cannot afford any symbol from any of the outside or external library, then you have to design the create the symbol using the library editor. I am focusing more about KiCAD KiCAD tool because we will be discussing the CAD tool, this KiCAD tool in this webinar. So the second point is the create symbol using the library editor, then schematic capture using EE schema, then create the footprints, then using the footprint editor, then generate the net list. This net list is very much important in the whole PCB designing, and using the this netlist is generated using the CBPCB. Then you will design the board layout, how much the board will be, like the size of the board, like 35 mm to 35 mm, 36 mm, somewhat like that. And the production of the PCB using Gerb view. This is a Gerber view. You can see the 3D view of the layers using this Gerber view. Then generate the BOM. BOM means bill of material. What all components you had used in designing the PCB or creating the schematic. So these are the major and the only key points to make the PCB from CAD to have the PCB in hand. So now it's time for the installation of the KiCAD tool. I will suggest to do this process with me because it takes a little bit time for the installation of the KiCAD. So just write KiCAD download. download KiCAD EDA, then having KiCAD is having its the open source terminal, or you can say the CAD tool, open source CAD tool. It is available for Ubuntu, Mac, Windows, whichever you want to use, you can use that. I have the Windows, I will select the window. Then you can check the system requirement if you wish to do so. If you have the Now click on this either on CER in Switzerland or the future Austria. I have the 64-bit system and the current version is available, that is 5.1.6. I will click on the CER in Switzerland and the system starts downloading. So yeah, this is just the installation process. You will select this save, and because I have the KiCAD, so I'm not downloading it again. So you can download this, and we will be back tomorrow with the schematic and what we will be doing. I'll show you that too. Like KiCAD is a cross-platform and an open source electronic design automatic suite. We will be doing a different webinar on Altium because it is the industrial software, like industry preferred that KiCAD. Uh, Industry preferred that Altium or Eagle over the KiCAD because it is more comparable or favorable to the high-speed circuit designing. I will be discussing about high-speed circuit designing while doing that webinar on Altium and Eagle. So the question arises, why we are doing the KiCAD if the industry uses that Altium and Eagle? Because KiCAD is a tool which defines the fundamentals of the PCB. Like you can see how things are going. In Altium and Eagle, you can't see how things are going. You can directly place the components and done. So we will be defining how things are going, how connections are to be done. If connections are break, then how you can see the connections are break using the DRC checker, which is the design rule checker. And what are we designing in this webinar? So we are designing the basic project, that is the water level indicator. You all of I think so you might have heard the water level indicator. Some of you might have in their water tanks in their home. So this is the schematic we will start designing from tomorrow at 4 p.m. So yeah, that's it for